The whole period?
All right, so yesterday we started talking about just some basics of some of the environmental issues, and we talked about human population growth and resource use, and now we start talking about some invasive species. So we're going to continue talking about environmental issues in a variety of contexts, and we'll talk a little bit about them, talk about causes, possible solutions, and so forth. So to start, water pollution. So there are different types of pollution, obviously, air pollution, water pollution, and pollution is basically when humans add some harmful material to the ecosystem. So if we're talking about water pollution, obviously we're talking about adding certain substances to bodies of water, rivers, streams, groundwater, lakes, oceans, that have damaging effects. So some examples of things that humans might add to the water: sewage. So sewage, which is basically what goes down toilets and drains in your house, should be going to a sewage treatment plant. So around here, anything that goes down the drains in your house, if you live out a ways and have well water, probably, you may have a septic tank at your house, where anything that comes out of the drains in your house goes down the drains, goes out to a septic tank, has a leach field, and goes into the ground. There's bacteria there, so that waste is sort of filtered and broken down by bacteria in the septic system. If you live in a place where you have municipal water and sewers, probably most of us, and when the stuff that goes down your drain goes through pipes in the ground, all of it goes down to North Utica to the sewage treatment plant, which is near like Babes and where Nicky Doodles used to be in North Utica, Moe's and Delmonico's, that area. Or off there, if you're looking at Delmonico's, off to the right is where the sewage treatment plant. All that wastewater goes in there. They have various means of filtering and cleansing it, and then that clean water gets discharged back into the Mohawk River. So that's the proper treatment of sewage. But in some areas, that doesn't happen properly, and sewage goes directly into rivers, streams, lakes, and that could cause problems. So sewage can carry disease, first of all, but also the waste that goes through those drains acts as a fertilizer in aquatic ecosystems, because there's lots of nitrogen compounds, organic waste, that can lead to the sort of excessive growth of plants in those areas where you have that pollution. Toxins like lead, mercury, PCBs, and other compounds that are dangerous to living organisms also are sometimes just discharged into the water. Now this used to be common. Industries would be built on lakes, and any waste from that industry, from that factory, would just be dumped into the water, dumped into rivers and streams and lakes. Today that's more tightly controlled, but it led to the pollution of huge bodies of water. In Syracuse, for example, Onondaga Lake, like the one that's right near Destiny, just see when you're driving in that area of Syracuse, that was once known as the most polluted lake in the country. That you were not allowed to swim in it, you're not allowed to fish in it, you're not allowed to be out on it on a boat. Since then, they've done a lot of remediation, and that came mostly from, there was lots of industry along that lake that just dumped their waste into the lake. There's been a lot of remediation to clean up the lake. It's now much, much cleaner. In fact, they were talking this year about allowing people to swim in the lake again because they've cleaned it up so much. So these problems can be, these issues can be cleaned up, but it takes a lot of money and a lot of time. Another thing is fertilizers and pesticides. You have to add that one in. It's not in your notes. Fertilizer, pesticides, things that are used in agriculture and golf courses, on your lawn. If you have service that comes to your house and sprays your lawn with those chemicals, that's fertilizers and pesticides. Some of that makes its way into the ground. Some of it runs off, can go into lakes and streams and rivers, and that again leads to problems. Even heat can be a type of pollution. So For example, this is an image shows a nuclear power plant that's built here on this dot. And what happens is these nuclear power plants they need a great deal of cooling in order to run efficiently. So what they do is they take in water from the lake, goes through the power plant. It's used to cool down the equipment and then discharged back into the lake. It's not polluted in any way with chemicals, but it is polluted with heat because the water that's discharged is much warmer than the water that went in. And warm water holds less oxygen and it interferes with some of the aquatic ecosystems. So those are some of the effects, excess growth of producers in an area, materials which can build up through the food web through biomagnification, reducing dissolved oxygen. So the solutions are what you probably would think about. Rather than disposing of waste in these bodies of water, we can properly dispose of it, treat it, store it. And that would result in less water pollution. We can try to more efficiently use pesticides, fertilizers, so that there's less runoff into lakes and streams and rivers. So we have gotten better at this. We have better controls, better laws and regulations which limit what industries can release into the water. So if we talk about using pesticides to destroy, insects that are eating crops, or to destroy mosquitoes or other organisms, if we're trying to limit the amount of pesticides we use, there are other alternatives, and one of those is using biocontrols. Biocontrols is sort of an alternative to using pesticides. And basically it's using some natural biological method to control the population of an organism. So some examples. Anyone ever seen these? Anyone have one of these at their house? What does it do?
Collects the beetles.
Yeah, what kind of beetles?
Japanese something.
Japanese beetles. So these are pheromone traps that trap Japanese beetles. If you ever have gone to your backyard and the leaves of plants are completely destroyed, they're just skeletonized almost, often that's due to these Japanese beetles. They're invasives. This trap has pheromones, which insects use to attract mates. And so Japanese beetles are attracted to these, they fall into the bag, and then they can't escape. And so this bag fills up with tons and tons of Japanese beetles. I was reading today, these may actually make the problem worse in your backyard, because what people are saying is not only they are trapping beetles, but they're actually attracting neighborhood beetles to your house, and only a small percent actually gets trapped, and then the rest are just chowing down on all your plants. So maybe not the best method. Sometimes scientists have sterilized male mosquitoes so they can't reproduce and release them into the wild, and they mate with female mosquitoes, but they're actually not fertilizing the eggs, and therefore the population drops. You could introduce predators. This has been done, even a virus. In Brazil, they introduced a virus to kill rabbits that were growing out of control. The loosestrife we talked about yesterday, in fact, is taking over marshes. There's a beetle called Coleoptera, which scientists are taking from Europe, importing here, because it eats the loosestrife but nothing else. And so we'll try to control it. Scientists are hoping it will control the population of loosestrife, but not affect the ecosystem in other negative ways. They're a type of flies that helps control fire ants by decapitating them. So there's all sorts of ways we can try to use natural predators and other means without relying on pesticides. Okay, air pollution, types of air pollution. acid precipitation. You've heard of acid rain? So acid rain is caused when humans release sulfur and nitrogen into the atmosphere. Often this is due to burning of fossil fuels, primarily. And in the atmosphere, this sulfur and nitrogen is transformed into sulfuric acid and nitric acid. And what it does is it lowers the pH of the precipitation, rain, snow, sleet, and so forth. And that's dangerous. Now, it's not that if you walk outside and you're in the rain, your skin is going to melt off. We're not talking about acids at that level. We're talking about a lower pH water, which can interfere with ecosystems. As this rain and snow falls in ecosystems, it causes the pH of soils, the pH of ponds, lakes to lower as well. And there are some fish and amphibians and other organisms that can't tolerate a low pH. And they start to die off. There are some areas where this is a major problem, areas that don't have soil that can buffer this highly acidic precipitation are most damaged. Examples of the Adirondacks are one area that's been affected significantly by acid rain. Spruce forests are dying because of this. There's some lakes that they become so acidic that nothing can live in them. They look like crystal clear, but it's not because sort of they're healthy, it's because all the organisms that once lived there are no longer able to survive. Here's an example. These are two gargoyles, one which was exposed to the elements, has been completely eroded. They once looked the same. And if you go to a graveyard and see the old graves that are made of limestone, they're like white colored ones, often the letters are completely eroded away because limestone interacts with acid rain, whereas like the newer granite stone doesn't interact with it. So we have worked to help to reduce this issue by requiring power plants to produce less emissions of sulfur and nitrogen. In cars, we have catalytic converters, which reduce the amount of pollution coming from the tailpipe. The more we reduce our use of fossil fuels, the more help we can do to prevent this problem. Here's a couple of graphs or diagrams. So this shows various pH levels going from almost neutral down to more and more acidic on this side. And it shows you what organisms can survive. So, for example, some of the freshwater mussels only can survive down to a pH of about 6 or so. And smallmouth bass, they start dying off at 5.5. And then salamanders, and brown trout, and lake trout. So if the pH of a lake, for example, gets down to 4.5 or 4, very few organisms can survive. Only a couple types of insects are able to survive. So as these ecosystems become more acidic, there will be more damage to these organisms. This map shows where acid precipitation is mostly a problem. And where is it? Red is more acidic precipitation. It's us. We live right in the heart of where acid precipitation is most affecting us. And part of the reason is because of the prevailing winds in the United States. Most prevailing winds go which direction? West to east in the United States. So pollutants released from the Midwest get carried in the prevailing wind currents and get carried eastward. And so in the eastern United States, we have a major problem. Another environmental issue is ozone depletion. You know what the ozone layer is? Have you heard of it? Where is it? Probably learned about it in earth science too. It's very, very high in the upper layers of the atmosphere. What do we call those upper layers? Come on, make Mr. Cleveland proud. What? No? Who's an earth science whiz? Nobody anymore? The stratosphere. So there is a chemical humans produce called chlorofluorocarbon, CFCs. And these CFCs were used for a long time in many different products. It used to be that all aerosol cans, can of hairspray or deodorant or spray paint, in it had a propellant, which is what made the substance come out, that was made of CFCs. What happened is these CFCs made their way very, very high into the atmosphere, and they destroyed a layer of the upper atmosphere called the ozone layer. Ozone is O3. And the ozone layer is very important to the health of organisms on Earth, because the ozone layer helps reduce the amount of ultraviolet radiation that's reaching the Earth. So if we reduce the ozone layer, we allow more ultraviolet radiation to the Earth's surface, and ultraviolet radiation is what causes things like skin cancer and eye cancer. So it gives you a sunburn. Ocean plankton are sensitive to ultraviolet radiation. So if the level of ultraviolet radiation reaching the Earth's surface increases, these plankton are affected as well. If we look here, this shows over from 1979 to 2014, shows the ozone hole, the size. The hole that formed was most pronounced over Antarctica. You can see there's this large area here. But the entire ozone layer had thinned out, allowing more ultraviolet radiation through. This graph shows the size of the ozone hole and the amount of ozone in the atmosphere. And do you notice anything about these graphs and about the problem? What can you conclude from looking at the size of the ozone hole over the last 30 years, 40 years? Anyone give me a conclusion based on this graph? No. What's happening to the size of the ozone hole in 1979 and onward at first? It's increasing. The hole is getting larger. But then what starts to happen? It starts to stabilize. And it stops growing. Same if we look at the ozone, minimum ozone. Again, ozone was dropping precipitously. But then we get around this point, and what's happening? Staying relatively stable. There's a reason for this, is that countries got together and they came to this, they met in Montreal, and they came to an agreement. They agreed to limit the use of CFCs in industry and everyday use, and that actually helped to improve this issue. Today, like spray cans and aerosols, they don't have CFCs in them anymore because of this Montreal Protocol. So we've seen that with cooperation between countries, we can have an impact on some of these issues. But it takes, if it was just one country that made a change, likely we wouldn't see these. We need widespread collaboration between multiple countries to address, because these are global problems. It's not like the ozone only in the United States is being affected, it's being affected globally. And another problem that's along that same line is climate change. So climate change is probably the biggest issue facing the Earth's population. That climate change is extremely important. It's changing rapidly, and it's changing because humans have been adding vast amounts of carbon dioxide to the atmosphere. Since when? Since the Industrial Revolution, basically. Since the Industrial Revolution, humans have begun to take fossil fuels out of the earth, coal, oil, natural gas, use them in factories, use them in cars and transportation and so forth. And for all of those fossil fuels that are combusted, results in the release of carbon dioxide. And so we have some graphs here I'll show you. But what happens is, as carbon dioxide in the atmosphere builds up, it acts almost as like it's a blanket over here that's thickening. Carbon dioxide traps heat. And as that heat is trapped, the overall temperature of the Earth is increasing. So let's look at this first graph. This shows carbon dioxide levels on Earth. So we can find the carbon dioxide level from long ago by looking at various things like air that's trapped in glaciers, or the amount of carbon dioxide in various rock compounds, things like that. So since this is 400,000 years ago, so we know the Earth has gone through periods of ice ages and periods of warming. And you see that cycle shown here, okay, where you have high levels of carbon dioxide and the Earth's temperature increases, low levels which result typically in ice ages as the Earth cools. Here's the last ice age. And now look at what's happened, where we are. If we look at this cycle, we are now up here, well beyond any of the previous 400,000 years. We look at since 1,000 years AD, when humans were not burning huge amounts of fossil fuel, carbon dioxide levels were here. Once we started in the Industrial Revolution using more and more fossil fuels, we have this dramatic increase in the carbon dioxide level. So the greenhouse effect is the name for the concept that carbon dioxide in the atmosphere traps heat, preventing it from escaping. So the more carbon dioxide we add to the atmosphere, it's like adding more and more blankets onto the Earth, warming the surface. If we imagine the Earth's energy balance with a very simple model, we have the source of energy coming in there is the sun. Solar radiation is what's responsible for all of the energy coming into the Earth. So that energy that comes in, some of it is absorbed by the atmosphere. The majority of it, some can be reflected. And that's not in this model, but some can be reflected. And much of it can be absorbed by the Earth's and ocean surfaces. Then the Earth can emit that energy back out into space. Some of that is radiating into space, some is trapped in the atmosphere. And it's this carbon dioxide and other greenhouse gases that reabsorb this energy being released by the Earth and keep it in the Earth's lower atmosphere, causing the Earth to warm. So, what does this mean for the Earth? Well, so scientists use models, computer models, to predict, very complex computer models, to predict what's going to happen to the Earth's climate as we continue to add carbon dioxide to the atmosphere. And predictions vary. Predictions vary based on lots of things. What are we going to do in the future? Are we going to limit our carbon dioxide use? Are we going to continue on the same path we're on right now? Are we going to continue to use more? And based on those various scenarios, scientists can use their models to predict what can happen. Probably right now, we are definitely going up 1.5 degrees Celsius. If we make pretty radical changes in the next 20 to 30 years, we might be able to limit it to 1.5. If we do not, then we're going to go to 2 or even more. And that causes serious global problems in a whole variety of ways. So, in recent research over the last year or two is when scientists have started to identify what kind of changes we need to make to keep our warming to 1.5. So if we look at, this shows temperature anomalies. This is basically how much has temperature changed from the average. So 0 would be average temperature. And again, we look at this graph going from before the Industrial Revolution to after, and obviously temperatures have risen. Okay? Each year is getting pretty much warmer than the previous year. The last decade have had almost all of our warmest years on record have been in the last decade. We know that the Earth is warming. Okay? And so when the Earth warms, there's a whole series of things that happen. So what are the predictions? Well, here are the results of various climate models. Okay? So again, these are different scenarios. The most optimistic scenarios in which we control our emissions and we make radical changes to our transportation, to our energy use, could leave temperature anomaly, okay, between 1.5 and 2 degrees Celsius. If we just sort of continue what we're doing now, we end up at these higher predictions. Earth's temperature can increase 3, 4, even 5 degrees Celsius. And that leads to radical change. So, what happens when the Earth gets warmer? Well, a lot of things. One of the most obvious things is that glaciers melt. We know that in the Arctic, we have glaciers. In the Antarctic, we have glaciers. We have ice caps. And as the Earth gets warmer, those things melt. And as the Earth's oceans get warmer, and as these glaciers melt, that leads to increases in sea level. Again, here we have global sea level. Okay? And we see the sea level has been rising. So it will continue as those glaciers melt, as the Earth warms. The other problem is that there is a positive feedback loop. Because ice, if you've ever been skiing and it's been sunny out, you can get a sunburn even if it's cold. Because what does that ice and snow do? Reflects a lot of that light. So the actual ice at the North and South Pole, as incoming solar radiation hits it, it reflects a lot of it. But as that ice melts, what does that mean is going to happen? If there's less reflection, where's that energy going to go? Into the water. It's going to be absorbed, and that's going to speed up heating, which speeds up melting, which speeds up heating, which speeds up melting. And so you have this self-reinforcing system in which increased warming leads to more melting ice, and that process repeats. So at the Arctic and the North Pole, okay, we've seen year after year sea ice being reduced. Summer sea ice is getting low. There may be a time in the coming near future when there's free passage of free water at the North Pole. So since humans have been traversing, there's never been a time when you could get through these waters with a boat without encountering ice. But there may be a time in the near future where there is free water at the North Pole. As the Earth's sea level rises, coastal areas get flooded. Sort of common sense. This is especially a problem for people that live near the coast. And if you imagine in the United States, people like to live near the oceans. Okay, think about major cities: Boston, New York City, Charleston, South Carolina, just trying to think this east, Miami, Florida, Fort Lauderdale. All of those major cities, Baltimore, are on the coastline. throughout the world, people build on the coast. They're great for food sources, they're good for transportation, and so people live near the coast. But as sea level rises, those areas get flooded. Many island nations are extremely concerned. Low-lying island nation, Indonesia, for example, has huge population of people on a series of small islands. Those islands are under great danger through this rising sea level. As the earth warms, the temperature of the ocean warms. Warmer oceans may sound great to go swimming, but the temperature of the ocean is what drives storms. As the temperature of the ocean gets warmer, hurricanes, tropical storms become more intense. Warm water holds less oxygen for the organisms that are in it. As ecosystems change, the abiotic factors are changing, the amount of moisture, the temperature, and many species cannot survive these new conditions and become extinct. One of the main reasons we are losing species at a rapid rate is due to climate change. Ecosystems will shift northward. So typically where you have a grassland at a certain latitude, as the earth warms, it's going to shift those ecosystems northward. Growing areas for different crops are going to change. Areas that were once good for growing a certain type of crop will no longer be good for that. Migration patterns change. Forest fires increase. Right now, the glaciers make up about 50% of what they were in the 1800s. Again, they have this positive feedback I was just mentioned about. Less ice, less reflection, more warmth. How does this affect humans? Well, like I said, agriculture. The growing season changes. Some areas it gets longer, some it gets shorter. It's predicted there will be more times of drought as the earth gets warmer. Cities that rely on flood barriers, for example, New Orleans, okay, or in the Midwest, the United States experienced great flooding in the Mississippi recently. Okay. Many of those areas are maintained using flood barriers, levees, and things like that. As sea level rises, those barriers will no longer be able to withstand that. Migration, so as people's homes flood, as drought increases, people need to find new places to live. They would call those environmental refugees, people that have had to leave their homes due to the effects of climate change and other types of environmental degradation. It's predicted there will be 150 new environmental refugees by 2050, and those people have to find a place to go. As we have more droughts, we lack drinking water. As temperatures warm, pollen levels increase, allergies increase, asthma increases. Insects that carry disease increase their range. The areas where malaria is endemic can expand. There's more frequent heat waves. So here's a graph that shows what happens to storm intensity. So, you probably remember hurricanes are category 1, 2, 3, 4, 5, higher numbers being more intense. Predictions are that as carbon dioxide levels increase, the number of category 4 and 5 hurricanes is going to increase. Okay, we have glaciers that are disappearing. So very pessimistic, right? Sorry. But that's the reality of where we are today. So it's going to be on you guys to make the changes that are necessary to try to address some of these issues. So how do we talk about a whole bunch of environmental issues. How do we address them? Well, there's a whole variety of ways we have. So one, population control. The more humans there are on Earth, the more intense all of these environmental issues get. So if we can control our population growth by means of education, by means of birth control, then we are going to help reduce those problems. To conserve resources, and by using more renewable resources, by recycling and reducing our use of disposable objects. We can help to conserve some of those resources. Governments can do various things. Something you're going to hear a lot about in the coming years are carbon taxes, carbon fees. So right now, for example, gasoline, the price of gasoline does not reflect its true cost to society, to the earth. Its cost is artificially low. If we add a tax to gasoline and coal and fossil fuels, that makes it more expensive. What the thinking is that would reduce the usage of those things, reducing the emissions of carbon dioxide. It would encourage people to switch to lower carbon fuels, to switch to renewables and so forth. In engineering, scientists are looking for ways to take carbon dioxide from the atmosphere and pump it into the ground or capture it in some way to reduce the levels of carbon dioxide in the atmosphere. It's called carbon sequestration. You'll be hearing about that as well. To help preserve species, refuges, preservations, protective laws can help to reduce the number of species becoming extinct. And legislation we know can work. So laws passed by the government can help some of these environmental issues. We have seen progress on many of these issues in the past decades due to the Clean Water Act, the Clean Air Act, Safe Drinking Water Act. However, there are some people that also feel that regulations should be reduced drastically, and that would mean less checks on these industries. We also need global cooperation. As we said, these are global problems that require cooperation between many countries. There have been attempts at this, some successful, like I talked about earlier, the Montreal Protocol, which limited CFCs. Others have not been as successful. To try to control carbon dioxide, there was the Kyoto Protocol, the most recent one, the Paris Accord, that tried to get countries from around the world on board to reduce carbon dioxide emissions. In the past couple of years, the U.S. has threatened to pull out of the Paris Accord. Okay, that almost every other country in the world has agreed to try to limit carbon dioxide emissions. And so, looking at, here's this word, go ahead, Kirsten. We're not done yet. So, trade-offs are something you will hear about. Trade-offs are when you look at both the positive and the negative side. You look at the costs and the benefits of actions in order to make informed decisions about what we are going to do. Another thing is to take long-term costs, like you're talking about this now. Taking long-term costs into account can help to reduce some of these issues. So that's it for environmental issues. Any questions?